Again we have an interesting question here. We've been asked to find out the depth of the lake at which the density of water is 2% greater than at the surface and the compressibility is given to be 15 to 10 to the minus 6 upon atmospheres per atmosphere. Now for solving this question, let this be the surface of the lake and let h be the required height when this density becomes 2% greater than at the surface. Let us consider a ball of water of mass m here and the same ball of water of mass m over here. Now this mass m is fixed, therefore this can be written to be density into volume. We differentiate both sides to get 0 is equal to rho dV plus V into d rho. Therefore rho dV plus V d rho is equal to 0. Therefore from this we get minus dV upon V is equal to d rho upon rho. Now we know the formula for bulk modulus is equal to minus dP upon dV upon V, where bulk modulus is always equal to stress upon strain. The stress is pressure dP and the strain is change in configuration, that is the change in volume upon original volume. We apply the negative sign to just make bulk modulus positive because dV is negative. Now therefore we know the value of minus dV by V to be equal to d rho upon rho. Therefore this can be written as dP upon d rho upon rho. Therefore d rho upon rho is equal to dP upon V. Now dP is the change in pressure on going from surface to height h. Let the pressure here be P naught. So the pressure here becomes P naught plus rho g into h. Therefore dP becomes equal to rho g into h. We need that the density of water is 2% greater than at the surface. Therefore the relative change in the density, this is the relative change in the density of water, that is equal to 2 upon 100 becomes equal to rho into g into h upon b. Now we know that the bulk modulus is equal to 1 upon compressibility. Therefore we can write this as into k, that is the compressibility given to be 15 to 10 to the minus 6 upon per atm. Now h comes out to be equal to 2 upon 100 into 1000, because the density can be taken to be 1000, into 10 into k, that is 50 into 10 raised to minus 6 per atmosphere. So atmosphere comes in the numerator. 1 atm is equal to 10 raised to 5 Newton per meter square. Therefore the final answer comes out to be equal to 4000 meters. This is equal to 4 kilometers. So a final answer for the depth of the lake at which the density of water is 2% greater than at the surface comes out to be equal to 4 kilometers. The important thing which you should have learned from this question is that B is equal to minus dP upon dV upon V, and this formula was used here, and the B is always equal to 1 upon compressibility. Using these two formulas we just differentiated this equation to get the final answer as 4 kilometers.